So in this video, we are going to discuss about scaling. So the digital filter must be properly scaled in order to prevent the overflow in fixed point limitations. Overflow is clearly a serious problem since the error introduced are very large. Therefore, in order to prevent the overflow, it is to scale the input to the filter such that the overflow cannot or unlikely to occur. So if you see this this is nothing but your IR filter, right? So h of z is equal to b naught plus b1 into z power minus 1 plus b2 into z power minus 2 divided by 1 plus a1 z power minus 1 plus a2 z power minus 2. So to avoid the we have to add to avoid the overflow, we have to add the scaling before the adder. So h of z is equal to s into this one. So I have added the scaling factor, that is s is added before the adder, right? So this is nothing but I have implemented this in direct from 2, the above equation, and I have added the scaling factor s, right? So I can write this h1 of z is equal to u of z divided by x of z, that is equal to s in s divided by 1 plus a1 into z power minus 1 plus a2 into z power minus 2. So if we solve u of z is equal u of z divided by x of z. So you will get the equation like this, and here the s represent the scaling factor, and once you to find the s is equal to 1 divided by root of I. So what is I? I is equal to 1 divided by 2 pi j closed loop function z is equal to 1 s of z into here it is nothing but h of z. Okay, h of z into h of z power minus 1 into z power minus 1 dz. So let us now realize following transfer function using that from 2. This is a question, and find the scaling factor in order to avoid the overflow in the adder. So they are given h of z is equal to 1 plus 2 z power minus 1 divided by 1 minus 0.6 z power minus 1. So this is your pole. Here you have to change the direction, change the sign, right? So this 0.6 to here you have to keep it like that. So this is as it is, so the 0, this one represent this one represent this one. Okay, so this is your direct from 2 representation, and I have added the scaling factor here. So h of z is nothing but y of z divided by x of z. So I am going to multiply wz multiply and divide by wz on both sides. So this is nothing but your wz. So I can write y of z by x of z is equal to this numerator, and w of z by x of z equal to 1 divided by 1 minus 0.6 z power minus 1 into s, right? So if I expand this equation, I will get y of z is equal to w of z plus 2 into z power minus 1 into w of z. So here if you solve this equation, you will get this one. So if you cross multiply these two function, you will get w of z minus 0.6 into z power minus 1 w of z is equal to x of z, right? So from this I can write w of z is equal to x of z plus 0.6 into z power minus 1 into w of z. Okay, so simply I can write this s is equal to 1 divided by 1 minus 0.6 z power minus 1, and we know that the s square is equal to 1 divided by I naught. So this is nothing but your s, and here I am going to find first, I am going to find the value of I naught. Okay, and this represent s of z. Okay, now this represent your s of z. Okay, so I naught is equal to 1 divided by 2 pi j instead of S of Z, you have to substitute 1 divided by 1 minus 0.6 Z power minus 1. Since it is Z power, if I substitute Z power minus 1 here, this becomes 1 divided by 1 minus 0.6 into Z power minus 1 into dz. Okay. So here, if I multiply, if I take this 0. Minus 6 of 0.6 outside, I will get Z Z minus 1 divided by 0.6. Okay. And here, if I take Z power minus 1 outside, I will get Z minus 0.6. So this Z inverse and this is Z inverse get cancelled out. And I have two functions, right? One is, if you see here, if I solve the value for Z is equal to 1.66 and another value is Z is equal to 0.6. Since the Z is unit circle, Z is equal to 1.66 is lies outside the circle, unit circle, right? So Z is equal to 0.6 lies inside the circle. So you have to take Z is equal to 0.6. Okay. So how to substitute this one? So in this equation, you take this alone and I have to substitute Z is equal to 0.6. Okay. So you can see I have taken this entire function and I am going to substitute Z is equal to 0.6. So if I substitute Z is equal to 0.6, you just cancel this term. Okay, you just cancel this term in this value. You have to substitute 0.6. Okay, so if you substitute 0.6, I'll get I naught is equal to 1.566. So in order to find the scaling factor S naught square is equal to 1 divided by I naught. So I will get S naught is equal to 0.7990. So the difference are where and when to apply the scale factor gain. So following the convention that each fixed point number represent a fraction, each node in the network must be constrained to have a amplitude of less than 1. So since the S naught value is less than 1, we can avoid the overflow. So this technique results in a lower signal to noise ratio. That is, signal to noise ratio is defined as SNR. So it should be noted that the choice of scaling technique generally depends upon the applications and it required accuracy. It is up to the designer to determine whether the fixed scaling or adaptive scaling must be used. So if you use a fixed scaling, the choice of the scaling factor will still depends on the applications. So I hope this video is useful for you. Thank you very much.